Appliance plans to order a microwave and stoves. Double check that I'm projecting that. Each microwave requires half hour to unpack and set up in the storeroom, and each stove requires 1 hour. The storeroom space is limited to 70 items. The budget of the store only allows for 60 hours of employee time for unpacking and setup. Microwave yields a profit of $30. Stove yields a profit of $50. How many of each should the store order to maximize the profit? And then wants to know how many microwaves and how many stoves. For a question like this, how is this related to what we've been studying? How is this the same thing as graphing and finding corner points? Well, the idea is, and the fundamental theorem of linear programming says that the optimal solution will land on a corner point. And I don't see a corner point. All I see is a story problem. So we have to find where's the corners, and then we have to maximize or minimize some kind of function. So that's the idea. All right. So what is it we're trying to maximize or minimize? How many of these should order to maximize profit? So I'm asked to maximize profit. Okay, well, what kind of profit do I have? It says a microwave is $30 profit. I'm just gonna let microwaves be X. And a stove yields $50. And we want to maximize that. How do I do that? Somehow, I do that by finding the corner points. The corner points of what? I don't see any graph listed. It says each microwave requires a half hour to unpack. Each stove, 1 hour to unpack. The storeroom has a limited space of 70 items, and it's only 60 hours. So I think I could make a time and space inequality. For time, I have a half hour for microwaves. And for the stove, it was 1 hour. And I only have 60 hours. And for the space, I only have 70 space for 70 items. So that would be time and space inequality. And I also claim that we can't have a negative amount of microwaves. We can't have a negative amount of stoves. That's not possible. So I think X and Y have to be greater than or equal to 0. You could have 0 microwaves, but you can't have a negative amount of microwaves. That wouldn't work. Okay, so that's 1, 2, 3, 4 inequalities, and we want to maximize the objective function somehow. So what we'll try to do is find where those corner points are on a graph, and then from there, hopefully we can find what the maximum profit yields. So I think we're in the first quadrant. Since you can't have a negative amount of microwaves, you can't have a negative amount of stoves. You can have 0, but you can't have a negative amount. I should somehow find the X and Y intercepts of this. So for this, it looks like X equals 70, Y equals 70. And here it looks like X equals that would be 60 divided by a half. So that's actually 2 times 60. You would also have y equals 60. So let's see, we have x equals 70, x equals 120. We have y equals 60, y equals 70. So the 120 and the 60 go together. 70 and 70 go together. And we need to find where are we on this graph? Where are we at on this graph? Does 0, 0 work? It seems like it does. If I plug in 0, 0 here, 0, 0 is solution. 0 is less than 60. 0 is less than 70. Seems like we're going that way. So I think we're stuck in that little region there. Okay, that's where I think we are. But what are the corner points? Like we have a corner point right here, right here, here, right there. That seems to be where they're located. What are those corner points? Seems like 0, 0, 70, 0, wherever these two intersect, and then you'd have 0, 60. So I'm not sure where this is. I don't know where that's located, but I think I could find it. I think I could just find the intersection of the two lines to give that to me. So maybe I'll do that now. So I need to find where do these two lines intersect. That's where that corner point is. If I multiply that time inequality by 2, then I don't have to deal with the fractions. So that seems like that would be x plus 2y equals 120. I think that's right. 2 times half is 1. 2y, 120, that looks right. And bringing this down, that's x plus y equals 70. Okay, if I subtract those, I would just get the y's. So that would give me one of the coordinates, and that might help me. So x minus x is 0. 2y minus y is y. And 120 minus 7, I guess, would be 50. So it seems like y equals 50 for the intersection. What's the x then? Well, earlier I had x plus y equals 70. So maybe I could find it there. I think that's 20. So now I found where they intersect, but it wants to know what's the maximum profit, maximum profit. So I've got my corner points. What is the max profit? Well, out of the corner points, I have 0, 0. I have 70, 0. I have 20, 50. And I have 0, 60. Okay. 0, 0 is pretty easy to calculate. That's 0. 70 times 30 would give me 210, I think. Another 0 on that looks a little better. 30 times 20 plus 50 times 50. 600 plus 2,500. And this one would be 50 times 60. So that'd be 3,000. Now, what is the maximum? Where does it lie? So the largest out of those, it wants the maximum profit. So I need to find which one was the largest. The largest occurs right here. So there's the largest. Where did that occur? It occurred at 2050. And that's right here. So that's where the max of the objective function lies. So I think it would be 20 microwaves, 50 stoves, $3,100 profit. So we use that objective function to either find the maximum or minimum of something. But the theorem states that that maximum or minimum of the objective function will lie on the corner point. So you have to find the corner points first. And our method of finding the corner points is graphically. Okay? If we introduced one more variable, we wouldn't be able to do it graphically anymore. You have to do something called simplex method. But for this one, we can just do it graphically since we only have 2 variables. If you had 3 variables, then you'd have a volume and you'd have to like rotate around some polygon to find it. That's not doable graphically. I mean, you can do it, a computer can do it, but not something you do by hand. Anyway, so that's how we did it graphically. Are there any questions about this?